Hello everyone and welcome to Programming for Beginners, episode number 3. In this episode, we'll talk about class, the building block of all object-oriented programming languages. This concept of class is one of the most important concepts in programming. I will not give you a definition for class because it would be useless. Instead, I will show you how you can define a class and how you can use it to make programming a lot more natural. Let's add another file to our project and we will define some classes there. In the Solution Explorer window, right-click on our project name, go to Add, select New Item, and here choose Class. Give a name to this file, myclasses.cs, and click Add. By default, Visual Studio adds some code to this file. We can keep everything except this class that it generated. We don't need this, we will define our own classes. The first class we want is the car class. And here is how we define it. As simple as that. The reason we named our first class car is because it's very easy to understand the next concepts if we find them in a real car. It just feels more natural. We will define now a second class named button. This is not exactly a real world button, but more like one of those buttons we used to click on when we created the game. This is a button, this is also a button, and this class is our button. These brackets are here to tell where the class starts and where it ends. The car class starts here and it ends here. All the code we write between these brackets is part of the car class. Now it is a good time to introduce the concept of namespace, this one that you always see at the beginning of the files. If we look at our game buttons, right-click on it and go to its definition, we can see there is already a class named button, but it is inside this namespace, while our button is inside this namespace. So this is the purpose of namespaces. They allow programmers to define classes with similar names as long as they are inside different namespaces. Now let's introduce the concept of field. Moving inside the car, we define a field named color and another named current speed. Both color and current speed make perfect sense for a car, but for our button, let's add only one field, the font size. These fields are also known as variables. The reason is simple, their value can change. Each field has a name, like color, current speed, or font size, and the data type, which tells what type of information that field stores. String is for text, and integer is for numbers. There are many other data types, which we will discover later. So we have our classes, and each class stores some information inside its fields. Let's keep some default values for these fields. So the car color can be red, its current speed 0, and for the button, the default initial font size, let's make it 60. Now let's focus on the car class and introduce the concept of method. We need methods to interact with our classes. Same as we need a wheel to steer a car, we need a method to control or interact with a class. The way we add a method to a class is this. For now, please ignore the two keywords, public and void. We will return to them in a second. Now let's add a method for our button class. And one method that would make sense for a button is, as you can see from their names, methods are meant to perform some action. So inside makeTextBigger method, the action that could happen is something like this. We take the font size field and make it 120. Inside the accelerate method, the current speed might take a different value like 100. At this point, our two classes are ready and we can use them. To understand how, we'll first introduce the concept of object. And the easiest way to do this is to think about cooking. Following a recipe, we can make as many cakes as we want. In this analogy, the recipe is the class and the cake is the object. So the class acts as a recipe, as a mold, or as a blueprint. It just tells how an object should be created. Just as we cannot eat a recipe, we cannot consume the class without first creating the object, the cake. So what we can do with our car and button classes is to use them to produce some objects. Let's move to the real world and imagine a car with a touch display which shows a big button with the text accelerate from 0 to 100. Now it makes sense to go to our car class and add another field called acceleration button. Now this field doesn't store a text, doesn't store a number either, it stores a button. So its data type should be button and its default value should be a brand new button. This acceleration button is a field that stores an object. By using the new keyword, we tell the computer to take the recipe for button, bake one, and give it to us to store inside the acceleration button field. But for simplicity, we can just consider that acceleration button is a button. It's much easier than to think about it as a field that stores a button. So the color is a text, current speed is a number, and the acceleration button is a button. Let's add another method to our car through which we can control the text size of the button. So we add public void increase text size. We could choose any name for this method, including make text bigger, but we'll keep them different to avoid confusion. And inside this method, we tell acceleration button to make text bigger. When you add a dot after a button, you see all its public methods and fields. If we make our method private, you will see an error. Because private methods are meant to be used only inside the class that defines them. That's why we don't see here any of the fields we defined, because we didn't specify the public keyword and by default they are considered private. If we try to use a private field, same error. But inside the class, the field can be used with no problem. What about this void keyword? A method can perform an action, do something, that's its purpose, but it also can return something. When it doesn't need to return anything, we use void. But let's assume we want our makeTextBigger method to return the result of its action in the form of success or fail. For that, instead of void, we specify the type of data our method is going to return. Let's use string because we already know it. And now, at the end of the method, we return success. Now let's go here where we call the method and store the returned result in a local field of the same type, string, and with whatever name we want, let's call it result. So we call the method, we take its result and store it in this field, which, unlike the other fields we already defined here, this is only visible and can be used inside the method. Now we could check if this result is success, and if it is not, we could display a warning message to the user. But we know that the result will always be success, because we always return success, so right now it doesn't make sense. What if we could tell our method how big we want the text? This is where parameters come into picture. When we call a method, we can also specify some values we want to send to that method, so we can use those values internally. In our case, we want to tell the method to make text this big, true 50. And the method must be informed that it should expect a number. We do this by changing its definition a little. Here, we tell the method it should expect a number, int, and it can use that number internally by this name, size. Now, instead of having this fixed number here, we replace it with size. Maybe we should also check the value of the size and use it only when it is smaller than 200. So if size is smaller or equal to 200, do this and return success. Otherwise, return fail. And this is how the method decides, based on some conditions, to use the received value or not. Now it makes sense to check this result, and if it is fail, maybe call the method again but with a smaller size. For simplicity, this time we don't store the return value in the result variable, but we could. And we could also recheck and call the method again until the result is success. But the purpose for now is only to know that we can send one or more values when calling a method, and it can also return a value. In this example, we only sent one value, the size, but we can send more, like this, as long as we inform the method by changing its definition. And the parameters can be of any data type. Let's add a string. And in the method definition, but since we don't have any use for these new parameters right now, I will remove them. By now, we know what a class is. It's a template for creating objects. And we know that we can make an object do what we want by adding methods. An object can have any number of fields that store different values of different types. In the next episode, we'll talk about properties and inheritance, and we'll change our button a little so we can use it in our game. Thank you, and don't forget to leave your feedback in comments.